Hey y'all, so as promised, these are the example problems I'm going to do from the worksheet that I posted on Schoology. I'm going to do the first 10 questions for you because this is also a little bit of a teaching lesson because this isn't in the PowerPoint and maybe not exactly self-explanatory. So we're just going to take a few minutes to go through the first 10 problems as sort of me showing you how to do it and answering those questions for you, and then y'all are going to do the last 10 questions on your own. Okay? All right. So we're just going to start at the beginning. What are the customary units of solubility on a solubility curve? So what that means is, if you look right here, this is the standardized unit we use for measuring solubility. It's grams of solute per 100 grams of water. So solute is the salt or the sugar or whatever is getting dissolved per 100 grams of water. So that's the standardized way that we measure solubility. So that's my unit. So it's grams of solute per 100 grams or 100 milliliters of water. That's the same thing. Okay. Number 3, according to the graph, the solubility of any substance changes as what changes? So if you look at the graph, the whole point of this graph is to show or indicate how the solubility changes as the temperature changes. So that's what that's talking about. So temperature. Number 4 says list the substances whose solubility decreases as temperature increases. All right, so if you look at this graph, can I zoom out a little? There we go. Look at this graph and notice that almost everything is pointing this way, right? Or swooping up this way, meaning the solubility increases as the temperature increases. But there are two things on this graph whose solubility decreases as the temperature increases. If you look at ammonia, so 0 degrees Celsius is the freezing point of water. So at the freezing point of water, you can dissolve about 90 grams of ammonia in 100 grams of water. But as I heat that water up, 100 is the boiling point of water. So at the boiling point of water, if I have 100 grams of boiling water, I can only dissolve about, what is that, 7 or 8, maybe, grams of ammonia in that same water, that same amount of water. And the other one that decreases is cerium sulfate. Okay, so do you see how everything goes up this way, but these two substances are pointing downward? They have a decreasing solubility. So ammonia, NH3, and cesium sulfate. So let's write those down. And on your worksheet, of course, it's drag and drop. So ammonia and cerium sulfate. Okay. Number 5 says, which substance is least affected by temperature changes? So it's hard to find. It's kind of camouflaged in here, and every year when I do this worksheet, it's kind of hard to find because it's almost a straight line and it kind of blends into the background, but you're looking for a substance that has a pretty flat line, meaning no matter what the temperature of your water is, you're going to be able to dissolve about the same amount of sodium chloride. This is sodium chloride's line. Let me highlight that for you because it is really hard to see. Look, it barely changes, right? Whether your water is freezing or boiling, it barely changes, right? It goes up from maybe that's 37 to 40 grams. So that is the one that appears to be least affected. Sodium chloride. Number 6 says how many grams of ammonium chloride, which is NH4Cl, can you dissolve at 50 degrees Celsius? So here's how you do this. On these types of questions, you're basically given two givens. I'm given my salt and I'm given my temperature. So I'm going to look and see where those two things collide. So find ammonium chloride and find 50 degrees Celsius. So here is ammonium chloride, this line here, okay? Find 50 degrees Celsius. Sorry I can't get this flat, y'all. 50 degrees Celsius, and run your finger up from 50 to where it collides with that ammonium chloride line, and it's right there, right? And the question is how many grams will dissolve, so then run your finger over, and it's 50 grams. So if you come up from temperature, go over to grams. If you come over from grams, go down to temperature, right? That's usually what you're doing on this graph. Okay, so the answer to this is going to be about 50 grams. Okay. Grams. Number 7 says, which two substances have the same solubility at approximately 78 degrees Celsius? All right, so I'm going to find 78 degrees Celsius, and I guess I'm looking for two substances that are crossing there, right? So 78 degrees Celsius is going to be not quite 80, but kind of between 75 and 80. I'm just going to run up and look. I look like I'm crossing right about there. I think that's pretty good. I think this is where I am. Maybe I should have called that more like 79, right? I might have on Schoology. I don't know. I might have caught that already. So these two lines that are crossing, this is sodium chloride and potassium. Oh, is that chlorite or chlorate? I can't remember. Chlorate, I think, but that might not be right. Anyway, so these are the two that are crossing here. So NaCl and KClO3 are crossing at 78 degrees. So let's write that down. NaCl and KClO3. Okay. Which compound is least soluble in water at 10 degrees? So all that means is look at 10 degrees and look for the one that will dissolve the smallest amount. That means it's going to be the first one you run into. Boop, right there. So it's potassium chlorate again. Okay. How many grams of potassium nitrate can be dissolved at 50 degrees? Now, this is what mostly your questions are like on the part of this worksheet you're going to be doing on your own. So make sure you pay attention to this. How many grams of potassium nitrate can be dissolved in 50 degrees Celsius? So we're going to see where those two lines cross, 50 degrees and potassium nitrate. Okay, so here's 50 degrees. Run my finger up until my finger hits the line that is potassium nitrate, and here it is, right there. And then run my finger over, and it tells me 80 grams. Okay, so 80 grams. And then I might do a little coloring to answer this. Are the following solutions unsaturated, saturated, or supersaturated? All right, so my first one is sodium nitrate. So let me show you what this means. For sodium nitrate, here it is. Just a quick lesson on what this means, all right? Let me get some colors. All right, so sodium nitrate, can y'all see this? No. Yeah, okay. So here is sodium nitrate. This is its saturation line or its solubility curve. And what that means is, let's see, the question is about 30 degrees, right? So what this graph means is at 30 degrees, this is how many grams of sodium nitrate, about 95 grams, will dissolve at that temperature, okay? So if I put in, so this is the saturation. If I have exactly 95 grams of sodium nitrate in the water at 30 degrees, that is a saturated solution. It cannot hold anymore. Okay, so I'm gonna write. I don't want to. I want to color it first. If I don't put quite that much in, what if I only put? What's this question? Okay, so this question is, I've only put 45 grams. So here's 45 grams at 30 degrees. That's where I am, right? So I've just said at 30 degrees, my water should be able to hold about 95 grams. If I've only put 45 grams of sodium nitrate in the water can hold more. So this water is unsaturated. So anything below this line is unsaturated. If I color, oh, I should use crayons for this. Summers, do you have any crayons in your desk? No, of course I don't. I have, and this is not a joke, like 5,000 sets of crayons behind me, but I'm going to be just a little lazy and not get them. Okay, my point is anything below the line is saturated. All right, so, oh no, sorry, unsaturated. Okay. What if the question had been, I have tried to stir at 30 degrees, 130 grams of sodium nitrate into this beaker of water. Here's what's going to happen. About 95 grams will dissolve, but this remainder will not. This is when you're in a restaurant and they give you iced tea that's not sweetened, and so you have to sweeten it yourself. And the first spoon, maybe, you can dissolve in the iced tea. And then after that, it doesn't matter how much you stir into the glass. It's never going to dissolve. It's going to end up at the bottom of the glass. And that's because the tea is already saturated at that temperature. All right, so this is the salt that's going to end up on the bottom of the beaker. It doesn't matter how much you stir it, it's not going to go. So if it's above the line, it is super saturated. What that specifically refers to is if I trick the water and boil the water, and if I boil this water and put all this salt in it, it will dissolve, and then I can cool the water down and it will stay dissolved. That's a fun little trick we can play on water, right? And so when we do that, if I had tricked this beaker of water into holding all this extra by heating it up and then cooling it down, back down to 30 degrees, that's now called a super saturated solution. That's like pancake syrup. That's how pancake syrup holds so much sugar, is they've boiled it and put a lot of sugar in it and cooled it back down. So that's a super saturated solution. So let me get a different color. Do I have green? Oh, I thought I had green. Oh, I have pink. I can do pink. There we go. I know this is not very good coloring, sorry. So to answer this question, right, this question says, I have 45 grams of sodium nitrate at 30 degrees. So 30 degrees, 45 grams, there it is. That is under the sodium nitrate line. That means this is an unsaturated solution. All right, so the answer to this one is unsaturated. And what's it if it's right on the line, by the way? If it's right on the line, it is saturated. Meaning it's holding exactly how much it can, not any more and not any less. That's what saturated means. Okay. Okay. Let's do the one more about that question. 60 grams of potassium chlorate in 100 grams of water at 60 degrees. All right, so 60 grams at 60 degrees. Let's find that. $60 grams at 60 degrees. Let's figure out where that meets. Kind of right in the middle of that, right? Ammonium chloride. And then let's compare that to, what is this, potassium chlorate? Where's potassium chlorate? That's a good question. Where is potassium? Oh, there it is. Okay. So here's potassium chlorate's saturation line. Okay. So just make sure you roll this through your brain and understand what this means. At 60 degrees, oh crap, that's class. Okay, I'm going to finish this real quick. At 60 degrees, I should be able to hold, oh, what is this? 25, maybe 26 grams. But I'm telling you, I have tricked the water into holding 60 grams. So this is a super saturated solution. Okay, that's it. The bell has rung. I've got to open my door and let kids in. I will get this posted as soon as I can. Make sure you get into Zoom if you have any questions about any of this, okay?